Welcome back. We've looked at a few videos and we've started to discuss the idea of what a limit is and how we find a limit. And in the last video, we talked about the fact that limits in some situations fail to exist, or rather, do not exist. We say DNE. So let's break that down and think about exactly what that means for a limit not to exist. So in these examples, we're looking at the limit of a function f as my x value approaches a being some real number, but it may not exist on the graph, meaning it may be an undefined point or a hole or even an asymptote. So for case one, if the function becomes infinitely large in magnitude, that means it looks like the y values either go to positive or negative infinity as x is approaching that number a from either side, the limit doesn't exist. So that means if we have a graph with, say, a vertical asymptote, and we have a limit on either side that's shooting up, that limit would approach positive infinity. And we're going to write positive infinity, even though infinity is a value that doesn't exist. We do not, in this situation, say do not exist. We would say positive infinity. Or if we had a situation where, say, we had a vertical asymptote and the graph was going down on both the left and right sides, we would say negative infinity. So that is a limit that does not exist, but we say as our answer negative infinity because it has direction. So that gives us a bit of context as to where our graph is tending, where it's headed. And then in the other situation, this is the situation where we will say does not exist. That means if we look at the limit from the left or the limit from the right, and I know that's new notation, but we say as we approach a from the left, so that's a little minus as a superscript, or a from the right. If we get these two values, L and M, from the left and the right, if they don't match, if they're not identical, that is the situation where we're going to write does not exist or DNE as our answer. So let's look at a graph and look at kind of all these different limit situations and how we would answer the question. Here I've given us a graph which has a lot of stuff going on. And we're going to look at 6 different limits, and I'm also going to include for us function values at each of these x approaches a values that we are considering. So we're going to work left to right across the page. And the first piece we're going to consider is as x approaches 6. So as x approaches 6 from the left, the graph seems to shoot up or tends towards positive infinity. And as we travel along the graph approaching x equals negative 6 from the right, x, or my y values, I should say, are going to negative infinity. Now, positive infinity and negative infinity are not the same value. Therefore, since these two limits don't match, the answer here is that the limit does not exist. And then, because I said I was going to talk about the function values, let's look at f of negative 6. So f of negative 6, is there a defined value at x equals negative 6? The answer is no, so we will write undefined. F of negative 6 is undefined. Let's move on to considering as x approaches negative 4. As x goes to negative 4 from the left, we can clearly see the output, the y value is noted here on the graph as 2. And as x approaches negative 4 from the right, we get a y value of 3. Now, since 2 does not equal 3, the limit here does not exist. Now, what about the function value? If I asked you to tell me f of negative 4, what would the output be? Is there a defined point at x equals -4? In this situation, we have this one dot right here at x equals -4. The open circle means undefined, so it is defined, the output would be 2. So f of -4 is 2. Now let's look at what happens as x approaches 0. As x approaches 0 from the left, we look like we're approaching what would be 3.4. And as x approaches 0 from the right side, again, we look like we're tending toward that same value. In this situation, the limit of the function is y equals 3.4. So we would just say that limit as x approaches 0 of f of x equals 3.4. However, if I asked you to tell me what is f of 0, what is the output, the defined y value at x equals 0, you'll notice we have a solid dot there at y equals 2. So the function value here, f of 0, is equal to +2. Next, we're going to look at as x approaches +3. So +3, we have this vertical asymptote. As we approach +3 from the left, it looks like my y values go towards -infinity. And as I approach +3 from the right, they also go down towards -infinity. Since both sides go towards -infinity, we're going to say that the limit of this function goes toward -infinity. Even though -infinity is a value that does not exist, and you can see that's written here, I've drawn over it, that's not what I want to see you write on your paper. I want to see you tell me -infinity. All right, so the limit technically doesn't exist, but the correct answer here is -infinity. If I were to ask you the function value for f of 3, is there a defined output? In this case, we're never going to touch that vertical asymptote, so the answer for f of 3 would be undefined. Let's look at what happens as x approaches +4. So we're looking at +4. +4 from the left, the y value we get is 1. +4 from the right, the y value that we get is 1. Therefore, since the limit from the left matches the limit from the right, and it appears they're both tending toward y equals 1 as x approaches 4, the answer here would be the limit as x approaches 4 of f of x equals 1. If I asked you to tell me the function value at f of 4, is there a defined point as the answer? In this situation, there is not. So again, we would answer that the function value is undefined. All right, one more. The last one we're looking here is as we approach +6. Approaching +6 from the left, we go to y equals 2. Approaching +6 from the right, we also go to this defined point at +2. So since the left and right match, we say the limit as x approaches 6 of the function is equal to 2. Now, what is the function value here? Is there a defined dot for f of 6? The answer is yes, we have this one dot defined on the graph. So the function value for f of 6 when x equals 6, y equals 2. So this is a really important concept to understand. You'll definitely see this, something like this on a quiz or a test. So you want to make sure you understand and know how to deal with this. Please let me know if you have any questions because I am certainly here to help.